Ever just grab a carton of milk and, trust that it's clean? Of course you do. Well, that trust is built on this incredible, high-speed, high-temperature industrial process. But how in the world does a dairy get a milk can, which gets used over and over, from totally dirty to perfectly sterile in just a matter of seconds? Okay, let's get into it.
We are going to pull back the curtain on what I'm calling the industrial cleaning gauntlet. And this is not just about soap and water. Believe me, this is a meticulously engineered war on germs where every single second and every single degree matters. It's all about keeping our food safe.
And this war, it's fought by a totally invisible army of machines. Seriously, from the moment that milk gets collected in cans to the pipes it flows through inside the factory, there is this relentless cleaning process that is the only thing standing between you and some really harmful bacteria.
So, where does a journey like this even begin? Well, we're going to start at the most basic level and then scale our way up, moving from a single can scrubbed by hand to the very first stages of automation. For smaller dairies, it all starts right here with the can scrubber. It's basically a super-powered mechanized scrub brush. You've got these two nylon brushes spinning in opposite directions, pretty fast, about 80 to 100 RPM, all happening inside a tank of warm 55 degrees Celsius detergent. It works great for one can at a time. But what happens when you have hundreds?
Yeah, to handle that kind of volume, you just can't rely on manual labor. It's not going to happen. You need a machine that can multitask. And this is where we see the first real, exciting leap in automation, the rotary cam washer.
I want you to think of this thing like a cleaning carousel. An operator loads a can upside down, and this whole platform rotates, but it stops at different stations along the way. At each stop, the can gets blasted from below with a different solution. First, a warm water rinse, then a high-pressure detergent jet that's up to 70 degrees, then another hot water rinse, then a blast of steam for sterilization, and finally, hot air to dry it all off. It's the six-step dance that cleans 3 to 6 cans every single minute.
But look, for a massive modern dairy, even that isn't fast enough. They need the industrial equivalent of a high-speed car wash, one that's designed to process just a relentless stream of cans with absolute maximum efficiency.
And this right here is where we see a huge leap in scale. We go from the rotary washer's stop-and-go carousel to the straight-through washer's continuous conveyor line. The movement never stops. And just look at that capacity. It more than doubles, sometimes almost triples, handling up to 16 cans a minute. This is the heavy machinery for the major leagues of dairy operations.
So this straight-through gauntlet is even more intense. Cans are loaded automatically and just sent right down the line. And notice how the temperatures keep escalating. A hot rinse at 70 degrees, then a caustic chemical rinse, followed by an even hotter rinse that's pushing 90 degrees Celsius. This progressive heating is absolutely crucial for what's coming next.
And both of the final stages hit this critical number, 110 degrees Celsius. Now, to put that into perspective, that is hotter than boiling water. This blast of dry, saturated steam just kills any microbe that could have possibly survived, and then the superheated air that follows makes sure the can is bone dry in an instant. That prevents any rust or, new bacterial growth from starting up.
Of course, a machine this complex and this powerful needs constant care. This is not a set-it-and-forget-it kind of system. Every single day, nozzles and strainers have to be cleaned out. Every week, valves and fans need to be inspected. And every quarter, the entire machine has to be descaled to fight off all that mineral buildup from hard water. It is a relentless schedule, but it's what's required to maintain peak performance.
Okay, so cans are one thing. They're made of sturdy metal. But what about glass bottles? They present a completely different engineering challenge. You need the same intense cleaning power, but you also need a delicate touch to avoid, shattering them all over the place.
The solution is the soaker-type bottle washer. So instead of just blasting the bottles, this machine is designed to gently guide them through a whole series of soaking tanks and really carefully calibrated jets. The key here is managing the temperature to prevent thermal shock. That's that sudden expansion or contraction that can just crack glass in a heartbeat.
And here is that journey. A single bottle takes about 20 minutes to get through this entire system. It starts with a gentle pre-soak at a mild 35 degrees. Then it slowly heats up to a 75-degree detergent bath. After that, it's carefully cooled back down in stages, from 65 to 35 and finally down to a 15-degree cold water jet before it gets discharged. This gradual change is the whole secret to getting them sparkling clean without any breakage.
So, we've cleaned the cans, we've cleaned the bottles, but what about the factory itself? We're talking about miles of pipes, these massive tanks, all the processing equipment. You can't just take that stuff apart every day to clean it. This is where the engineering gets truly, truly brilliant.
It's called cleaning in place, or just CIP for short. And this is basically the factory's automated self-cleaning immune system. Without taking a single pipe apart, the entire system can flush itself with a sequence of rinses and chemical solutions to sterilize every single surface that the milk touches. It's amazing.
Now, for CIP to work, everything has to be perfect. The temperature needs to be just a few degrees above the melting point of milk fat to dissolve it. The velocity of the cleaning fluid has to hit this sweet spot of 1.5 meters per second, fast enough to create turbulence that scrubs the pipes, but not so fast that it's inefficient. It's this delicate balancing act of chemistry, physics, and engineering.
And there are two main ways dairies do it. The single-use system is for smaller jobs, like cleaning just one pasteurizer. It uses the cleaning solution once and then it's down the drain. But for the whole plant, the reuse system makes way more sense economically. It has these central tanks that store, recover, and replenish the cleaning chemicals, circulating them all over the factory before returning them for the next cycle.
Ultimately, the goal here is total, reliable automation. This quote really gets to the heart of it. To ensure consistent safety and to prevent any human error, especially with these hazardous chemicals, the entire cycle, from the temperatures to the timings to the chemical concentrations, is all controlled by a computer with as little human intervention as possible.
So, the next time you open a carton of milk, you'll know about the invisible gauntlet of steam, chemicals, and high-pressure jets it had to pass through. It really makes you wonder, right? What other incredibly complex, invisible engineering is working all around us, protecting us every single day?